In this question, we have to find the surface area of this cone. The surface area of the cone would include the circle at the top. And let's move that over to the side here, and maybe we'll shrink it down a little bit. And it would also include the lateral surface area of the bottom part. Yeah, so we'll move that over here and shrink it down too. So the surface area is equal to the top circle part plus the cone part. Now we know what the area of a circle is. It's given by the formula pi r squared. And we also know what the formula for the lateral surface area of a cone is. It's given by pi r L, where L is the slant height. So what we need to do is find values for r and for L. So if we look at our diagram, we're given the diameter of the circle at the top. So the radius would be half the diameter, or this distance right here. So r would equal 5 centimeters. And L would be this distance here along the edge of the cone. But we're given this distance here, which is the height of the cone. In other words, the height of the cone here is equal to 12 centimeters. So how do we find L? Well, we can use the Pythagorean theorem because this shape here is a right angle triangle. So the Pythagorean theorem states that L squared is equal to h squared plus r squared. So if we plug our values in, we would get 12 squared plus 5 squared. And that would give us 144 plus 25. So L squared is equal to 169. So L is equal to the square root of 169, which happens to be 13. So now we have all the information here to work out the surface area. So this becomes pi, which is 3.14, times the radius, which is 5 all squared, plus pi, again, is 3.14 times 5 times 13. So 5 squared is 25 times 3.14 is 78.5. And 13 times 5 times 3.14 is 204.1. And when we add those together, we end up with 282.6. And the units here is area, so that would be centimeters squared. And if we look down our list of options here, we can see that B is the closest area of the cone. And there you go.